So last week, we talked about the methods necessary to factor a quadratic trinomial like this one, x squared minus 4x minus 21. If I were to ask you to factor this, what would you do first? What would you think about first? Where would your mind go? Where would your pencil go? Looking at this trinomial, the first number that your eyes are drawn to, right, once you've practiced these problems a lot and you've gained that expertise, the first number that you zero in on is that 21, right there. And you ask, what paired factors can I multiply together to give me 21? Because that, actually negative 21, right? And so you run through the list. 21 and 1 is one possibility, but the other possibility is 7 and 3. And 7 and 3 looks like it has a better chance of being the right pair because we also need that pair to add together to give us negative 4, the coefficient in the middle. And so one of these has to be positive and the other one has to be negative. Which one do we want to be negative? The 7. Exactly. The bigger number gets the negative because the sum needs to be negative. So negative 7 and 3 is a pair of factors that we can use to factor x squared minus 4x minus 21. And so to finish the factoring process, what do we then do with the numbers negative 7 and 3? I'm going to draw out this process a little bit for this example because we're going to have to draw it out again, and it's almost necessary to draw it out in the technique where we're going here in a minute. So we're trying to factor x squared minus 4x minus 21. And so my middle terms here have to add together to give me negative 4x. My x squared is going to come from multiplying what by what? This is always how we make an x squared. Factoring is an x times an x. And now we decided by playing the sum and product game that we want to make that negative 21 out of a negative 7 and a positive 3. Because that's going to give me the negative 21 that I want in the lower right-hand cell of this table. And now we'll just fill in the rest of the table. Multiplying the x by the negative 7 gives me in the upper right negative 7x. Multiplying the x and the positive 3 is going to give me positive 3x. And sure enough, when I combine the like terms in those two cells, I do get the negative 4x that we needed. So this is the factorization that works. And all we needed to do was we needed to play the sum and the product game. X minus 7, x plus 3. But there's one step in this factoring process that we didn't have to pay attention to here, but we will have to pay attention to when we make this more intricate. And that was this step right there. The step where we got an x squared by multiplying an x and an x. That works great as long as there's not a coefficient in front of the x squared. Right? The coefficient in front of the x squared in our original problem here is just a 1. And there's only one way to make a 1 by multiplying integers together, a 1 times a 1. So we don't have to think about that step. But as soon as we have a coefficient in front of the x squared which is no longer 1, now that opens up a can of worms. It opens up possibilities for things not to work as well as we thought that they might. So let's try applying the same process to the example on the left. So working from the inside of my table to the outside, I'm going to first get the first and the last terms in place, 3x squared and negative 21. And we might well say, well, let's try factoring the negative 21 in the same way we did before. This is just a guess right now. So I'm just going to guess that I'll put a negative 7 and a positive 3 there. But then we come to this 3x squared part of the table and ask, well, how am I going to factor that? So how am I going to make a 3x squared out of a product of two lower order terms? What do you think? If I can't do it with just an x and an x, what should I do? Okay, so my 3 is going to come from a 3 in one of the coefficients and a 1 in the other. And my x squared is still going to come from x and x, right? But the problem is, now it matters if I put that 3x on the first row with the minus 7, or if I put that 3x on the first column with the plus 3. Right? So this is the big question mark now, is should I flip-flop these two? Because we didn't have to worry about that before. When it was just an x and an x, it didn't matter. But now it matters. Also, what if instead of 3x squared, this were a 4 instead? Now not only do we have the order problem, but we also have other possible ways of factoring 4. It could be a 4 times a 1, but it could also be a 2 times a 2. Right? So there's all these other possibilities that we would have to think about if we were going about this sort of with brute force. Now we can guess and check, and to be perfectly honest, guessing and checking is how I learned to do this factoring when I learned algebra back in the day. It wasn't until I taught this class, like a year or two ago, that I learned that there was a better way, a more systematic way, a way that can avoid guessing and checking that actually is really cool. So that's the way that I want to go through with you. But if we were in guessing and checking mode, we would then just try multiplying this back out, minus 7x. But then I'll get in this bottom left hand, 3x times 3 is going to give me 9x. And I would add these together, and I would get 3x squared minus 7x plus 9x. It's going to give me plus 2x minus 21, which gets us really close, but the 2 should be a negative 2, so it didn't quite do it. Fortunately, I could fix that. How should I fix that if I want to get a negative 2 here in this middle coefficient instead of a positive 2? Yeah, let's change the sign on the negative 7 and make it positive 7. And then I'll also have to change the sign on the positive 3 and make it negative 3. That's still going to give me a negative 21 in the lower right, but it's going to interchange the negative 7x on the upper right, and the negative positive 9x will become negative 9x in the lower right. And now I do get 3x squared minus 2x minus 21. So guessing and checking can get me there, right? It shows me that 3x plus 7 times x minus 3 is my factorization. But we had to do some hunting around and some lucky guesses along the way. So what I want to do next is look at a way to do this that doesn't rely upon us taking lucky guesses and taking the time to check them.